Welcome to the world of hidden history. If you enjoy this video, smash that like button and hit subscribe. It really helps the channel. Today, we're diving into the fascinating realm of coronal mass ejections, or CMEs for short. In layman's terms, CMEs are massive bursts of gas and magnetic fields being released from the sun. They're like solar superstorms, hurling billions of tons of coronal material into space at incredible speeds. But what does this mean for us on Earth? How have these solar phenomena shaped our past, and how might they affect our future? We'll be exploring these questions and more as we delve into the history of CMEs, their impact on our culture, and the potential effects they could have on our technologically driven world. So buckle up for a cosmic adventure that's truly out of this world. Now let's journey back in time to when CMEs were first discovered. The journey of understanding coronal mass ejections, or CMEs, started in the late 19th century. The first observations were made by pioneering astronomers using the solar telescopes of the time, which were quite primitive by today's standards. These early observers noticed something peculiar: large, bright eruptions occurring on the surface of the sun. They named these events solar prominences, but it would take many more years of study to fully comprehend their true nature. Our understanding of these solar prominences took a significant leap forward when British astronomer Richard Carrington made a landmark observation in 1859. He was studying solar spots when he witnessed an intense brightening event, which we now know to be a solar flare. This was the first time a solar flare had been observed directly, and it marked a turning point in our understanding of the sun's activity. Carrington's observation sparked a flurry of interest and further study. Over time, scientists began to draw connections between solar flares and the earlier observed solar prominences. They started to realize that these were not isolated events, but interconnected phenomena. Solar flares, they proposed, were the catalysts, triggering the larger, more dramatic solar prominences, or as we now call them, CMEs. This realization, however, was just the beginning. It paved the way for a more in-depth exploration of these solar events. Scientists began to study the relationship between solar flares and CMEs more closely, using increasingly sophisticated equipment and techniques. They scrutinized the sun's magnetic fields, its rotation, and the complex interplay of forces that could lead to these intense eruptions. As technology advanced, so did our understanding of these powerful solar phenomena. We began to grasp their scale, their power, and their potential impact on our world. But as with any journey of discovery, each answer only led to more questions that continue to drive our exploration of the sun and its mysterious CMEs to this day. Fast forward to the space age, our understanding of coronal mass ejections, or CMEs, took a giant leap. With the advent of space-based observatories, our eyes were opened to the dynamic, often tempestuous nature of our sun. No longer limited by Earth's atmosphere, these observatories provided unobstructed views of the sun's activity, including the dramatic spectacle of CMEs. These eruptions, once mysterious, could now be studied in more detail. We discovered that CMEs were not mere solar tantrums, but complex, powerful phenomena with far-reaching effects. When these solar particles hurtle towards Earth, they interact with our planet's magnetic field, often triggering geomagnetic storms. Imagine a cosmic dance, where the sun's energetic particles swirl with Earth's magnetic field. This dance can lead to stunning displays of northern and southern lights, known as auroras. However, it's not all just a beautiful spectacle. These geomagnetic storms can also have less desirable effects, like disruptions in satellite communications and power grids. Equipped with this knowledge, we began to understand the broader impact of CMEs on our planet's magnetosphere. This region around Earth, dominated by our planet's magnetic field, acts as a shield against harmful solar and cosmic radiation. But when a CME hits, it can cause temporary disturbances in the magnetosphere, known as geomagnetic storms. The more we learned, the more we realized the importance of monitoring and understanding these solar eruptions. Today, space weather forecasting is a crucial part of our efforts to mitigate the potential impact of CMEs. We continually monitor the sun's activity, ready to alert satellite operators, power companies, and others who might be affected by a major solar event. Yet, despite these advancements, predicting CMEs remains a challenge. Their frequency and intensity can vary, and not all CMEs affect Earth. The sun, it seems, still holds many secrets. But with each new discovery, we're getting closer to understanding and preparing for these cosmic tempests. While we've learned much about CMEs, predicting them remains a challenge. These solar events don't just influence our planet, they've also had a surprising influence on our culture. Indeed, coronal mass ejections, or CMEs, have permeated our cultural consciousness in more ways than one might think. From the ancient civilizations who wove tales of gods and mythical creatures around the celestial events they observed, to modern artists who capture the ethereal beauty of these solar phenomena, CMEs have long been a source of inspiration. They've been the muse behind countless pieces of art and literature, their mysterious allure sparking creativity across various mediums and cultures. Perhaps the most famous example is Edvard Munch's iconic painting, The Scream. While some attribute the dramatic sky in the painting to the artist's mental state, others believe it was inspired by the vivid red skies caused by a powerful solar storm in the late 19th century. This is just one of the many ways that CMEs have found their way into our cultural fabric. But it's not just art and literature that have been influenced by these solar events. Intense CMEs can cause geomagnetic storms that have the potential to disrupt our electrical systems. This realization has fueled a certain level of fear and apprehension, and has been the basis for many a science fiction story. The thought of a world plunged into darkness by a potent solar storm has served as a compelling plot device in books and movies alike. Despite the potential for disruption, CMEs have also served as a reminder of our place in the cosmos. They highlight our vulnerability to the whims of the sun, yet also our resilience in the face of such cosmic phenomena. This duality has permeated our cultural narrative, influencing how we perceive and interact with the universe beyond our planet. Just as CMEs have shaped our past, they'll undoubtedly influence our future. As we continue to explore and understand these solar events, they will continue to inspire and challenge us, shaping our culture in ways we can only begin to imagine. What does the future hold in the face of these mighty solar eruptions? It's a question that not only intrigues us, but also challenges us to prepare and adapt. As we move towards a future that's increasingly dependent on technology, the potential impacts of coronal mass ejections, or CMEs, take on a new dimension. Consider our reliance on electronic devices. From smartphones to electric cars, from power grids to satellites, our society thrives on technology. But here's the catch. CMEs, with their powerful bursts of solar plasma, have the potential to disrupt these devices. A large-scale CME event could cause widespread power outages, leaving cities in the dark, and could even knock out satellites, crippling communication networks. It's a sobering thought, but it's one that's driving us towards developing more resilient technologies and strategies to mitigate these risks. Looking beyond Earth, the potential future impacts of CMEs become even more profound. As humans venture further into space, whether it's establishing a colony on Mars or exploring the outer reaches of our solar system, we will inevitably face the challenge of protecting ourselves from the effects of CMEs. These solar eruptions can pose serious risks to astronauts, potentially damaging their spacecraft and jeopardizing their health due to high radiation levels. Developing effective shielding technologies and early warning systems will be crucial for the safety of these brave pioneers. But let's not forget, CMEs aren't just about risks and challenges. They also present opportunities. For instance, studying CMEs could provide invaluable insights into stellar activities, not just in our sun, but in other stars across the universe. This could open new doors in our understanding of the cosmos, and who knows, it might even lead to groundbreaking discoveries in astrophysics. As we continue to explore the cosmos, our relationship with CMEs will evolve, opening new chapters in our shared history. It's a journey filled with uncertainties and challenges, but also endless possibilities. And that's what makes the future so incredibly exciting. From their discovery to their future impact, coronal mass ejections, or CMEs, are a fascinating part of our universe. We've journeyed through the annals of history, tracing the early studies of these solar phenomena to our modern understanding of their composition and behavior. We've explored their cultural impact, how they've inspired awe and fear, and influenced our artistic and literary expressions. and we've looked ahead, contemplating how these celestial events might shape our future, both technologically and culturally. As we stand at the precipice of further exploration and understanding, we're reminded that the universe is a vast, dynamic landscape, teeming with phenomena that challenge and inspire us. As we unlock the secrets of these solar phenomena, who knows what discoveries await us? Stay tuned to Hidden History for more fascinating insights. And remember, if you enjoyed this video, smash that like button and hit subscribe. Thanks for watching.